All right, so let's look at the next example. Let's say consider the unit circle. The equation x squared plus y squared equals 1. Find the equation or the equations of tangent line or tangent lines to this curve at x equals 1/3. So x value is given as 1/3, y value is not given. And we want to find and the slope is not given as well, of course. And we want to find the equation of tangent line or tangent lines if there is more than one. So first, let's look at the graph. We know how the unit circle looks like. And at x equals 1/3. At x equals 1/3, we have 2 points of intersection, right? So 1 point here and 1 point here. So we have 2 points on this circle with x value of 1/3, one in the first quadrant and one in the fourth quadrant. So since we have 2 points of intersection, 2 points with the x value of 1/3, 2 points on the circle with x value 1/3. So naturally we expect 2 tangent lines. 1 tangent line at each point. So we'll have 1 tangent line here. And also 1 tangent line here. So according to the figure, we expect 2 tangent lines. One with a negative slope at the first quadrant. One with a negative slope, which is a tangent to the graph, tangent to the circle at the first quadrant. And one with positive slope, tangent to the graph or tangent to the circle at the fourth quadrant. Okay, see this green line here, tangent to the graph in the first quadrant has a negative slope because the angle with the horizontal line is more than 90 degrees. And this blue line here, tangent to the graph at the fourth quadrant, has a positive slope because the angle with the x-axis is less than 90 degrees. So that's what we expect to get. Now we have to do a calculation to verify this. So x is equal to 1/3. So in the exam, you don't have to write down this part, that what we expect to get, right? So you can just do the calculation, and if the question asks you to sketch the graph, well, then you have to sketch the graph. Otherwise, if the question does not ask you to sketch the graph, you don't have to sketch the graph either. So I'm just writing these explanation and drawing the graph just for clarification and so that you can understand better. So x is equal to 1/3. Let's first find the y value. What is the y value? We know that x squared plus y squared is equal to 1. So 1/3 squared plus y squared is equal to 1. So y squared equals 1 minus 1/9. which is 8 over 9. And therefore y is equal to plus minus root 8 over 3. Plus minus root 8 over 3. So we have 2 points here. So let me call the point. Let's say this one, I can call it point A. And this one, let's call it point B. So point A in quadrant 1, A will be x value was 1/3, y value is root 8 over 3. And then you have y minus y naught equals m times x minus x naught. And what is the m? M, we need the derivative for m. So what is the derivative? It's going to be dy to dx at the point 1/3 and root 8 over 3. So to find y prime equals dy to dx, use implicit differentiation. So implicit differentiation, we said what? We said we have to differentiate both sides of the equation using derivative rules, of course. So here the equation is x squared plus y squared equals 1. So then in the left-hand side, if I want to differentiate, derivative of x squared is 2x. Derivative of y squared is 2y, y prime. So that's the only important thing, that derivative of terms containing y must be computed using chain rule. Chain rule says, if you differentiate a function respect to u and a function u respect to x, it's the usual derivative f prime of u times u prime. In this case, it's 2y times y prime. So 2x plus 2y y prime equals derivative of 1, which is 0. And therefore, then we have to isolate for y prime. So 2y y prime equals minus 2x. And then divide by 2y. Of course, y, if y is not equal to 0, or y not equal to 0. In our case, of course, y is not 0, right? Because ultimately we want to calculate the derivative at this point 1 over 3 and root 8 over 3, where x and y are both non-zero. So then y prime will be equal to minus x over y. And then we can say that y prime equals dy to dx at the point. Now we have to calculate derivative at the point. So m is equal to dy to dx at the point a, which is 1/3 and root 8 over 3, or y prime at the point 1/3 and root 8 over 3, which is minus x over y at the point 1/3 and root 8 over 3. And that's going to be minus 1 over 3 divided by root 8 over 3. The answer is minus 1 over root 8. So this is the slope, minus 1 over root 8. And therefore, equation of the line will be y minus, we said here, y minus y naught equals m times x minus x naught. We have x naught, y naught here. So y minus root 8 over 3 equals m, which is minus 1 over root 8 times x minus 1 over 3. Similarly, at B, what will be the coordinate of B here? B, at B, y value is negative. So 1 over 3 and minus root 8 over 3. 1 over 3 and minus root 8 over 3, which will be in quadrant 4. What will be y prime? Y prime will be equal to, still same formula, of course. So slope m will be equal to y prime at the point 1 over 3 and minus root 8 over 3. And this is minus x over y at the point minus root 1 over 3 and minus root 8 over 3. That's going to be minus root 8 over 3. So minus x over, so x is 1 over 3 minus root 8 over 3. And then this will be, so x is 1 over 3, y is minus root 8 over 3. So the answer will be positive 1 over root 8. So m is 1 over root 8. And therefore equation of the line will be y minus y naught. Y naught is minus root 8 over 3 equals m, which is 1 over root 8 times x minus x naught, which is 1 over 3. And therefore y plus root 8 over 3 equals 1 over root 8 times x minus 1 over 3. So this is consistent with our expectation. This is the line tangent to the graph in quadrant 4, which has a positive slope, as the picture suggested earlier. The line tangent to the graph at quadrant 4 has a positive slope, and the line tangent to the graph at quadrant 2, which is this line here, has a negative slope, which is this green line here. Okay. All right, so let's look at the next example. Find dy to dx if, now the equation is, let's say 5y squared plus sine y equals x squared. So this is an implicit equation because it's not written of the form y equals f of x. It's an implicit equation. And we want to use implicit differentiation to find y prime equals dy to dx. So what was the first step? So first, again, if you remember, differentiate from both sides, or differentiate both sides. Both sides respect to x. So what do we get? 5y squared plus sine y sine y derivative. So this is the derivative of left-hand side equals derivative of x squared. Now, we said that we have to remember the derivative of terms containing y must be computed using chain rule. So what is derivative of 5y squared? Derivative of, like if it was 5x squared, the derivative would be 10x, right? So derivative of 5y squared would be the usual derivative 10y, but then times y prime, because it's the derivative of y and then it must be multiplied with y prime. So 10y times y prime plus, now again similarly, derivative of sine y, the usual derivative, which is cos y, but then multiplied with y prime. See, the rule is very simple. Always multiply with y prime. So plus y prime times cos y equals derivative of x squared, which is 2x. So then I can take y prime out. 10y plus cos y, right? So this is basically the next step. Isolate for y prime. which is already done because all the terms containing y prime are already on one side. Isolating means, keep all the terms containing y prime in one side, other terms other side. Is already done. And next, solve for y prime. How can I solve for y prime? I can take y prime as a common factor, right? So I can take y prime out from the first two terms. So y prime times 10y plus cos y equals 2x. And then y prime will be equal to 2x, y prime or dy to dx will be equal to 2x divided by 10y plus cos y. Okay, that's it. We just want to find y prime or dy to dx. Now the next example, find dy to dx. So it's a part A. Let me say, write it this way. So consider the curve with the following equation. X to power 3 plus y to power 3 equals 3xy. Now part A, we want to use implicit differentiation. To find dy to dx. Part B, find the equation of the tangent line. Find the equation of the tangent line to this curve at the point 3/2 and 3/2. And part C, at what points? At what point or what points in the first quadrant is the tangent line to this curve, is a tangent line to this curve. Or is a tangent line horizontal? By tangent line, I mean tangent line to the curve, of course. Okay, so first we want to find dy to dx. Now again, the very first thing is to look at the equation. Is it an explicit equation or implicit equation? If it's explicit equation, like y equals a function of x, then just use derivative rules, find y prime. If it's an implicit equation, use implicit differentiation to find y prime. Here is an implicit equation because the connection between x and y is given, but not of the form y equals a function of x. It's not y equals a function of x here. All right? It's x cubed plus y cubed equals 3xy. So it's a mixture of x and y. And this is an implicit equation. So we have to use implicit differentiation to find y prime or dy to dx. So for part A, so what were the steps? First, differentiate both sides. We know that the first step is to differentiate both sides. Then we get x cubed plus y cubed derivative equals 3xy derivative. Now what is derivative of x cubed? Derivative of x cubed is 3x squared. Derivative of y cubed is 3y squared times y prime derivative of terms containing y is the usual derivative times y prime according to the chain rule. So this is derivative of left-hand side. Now, what about the right-hand side? Right-hand side, I have 3x times y, so it's product of two functions, therefore I need product rule. So it's going to be 3x derivative times y plus 3xy derivative. So then we get 3x squared plus 3y squared times y prime equals the 3 times derivative of x. Derivative of x is 1, so 3y plus 3xy prime. So we differentiated both sides. Then we have to isolate for y prime. Next, isolate for y prime. Then we get 3. Isolate for y prime means, as we said, taking all terms containing y prime into one side and other terms into other side. So 3x squared y prime minus 3xy prime equals 3y minus 3x squared, right? See, there are two terms that contain y prime, this term and this term. I took them to left-hand side, and then the other two terms to the right-hand side. And then this gives, if I take y prime, so next isolate for y prime. Next, solve for y prime. So if I want to solve for y prime, I can take y prime out, take it as a common factor, take it out as a common factor. So y prime times 3x squared minus 3x. So 3y squared. Here I made a mistake. This term, the two terms containing y prime, 3y squared y prime and 3xy prime. So 3y squared y prime. So 3 times y prime, take it out, 3y squared minus 3x equals 3y minus 3x squared. And therefore y prime will be 3y minus 3x squared divided by 3y squared minus 3x. So I can take 3 out and cancel 3 from top and bottom. Then y minus x squared divided by y squared minus x will be left. So y prime equals dy to dx equals y minus x squared divided by y squared minus x. So this is the answer for part A. For part B, it's very simple. The equation of tangent line is asked at a specific point, 3/2 and 3/2. Well, we know the derivative and we know the point. We can find the slope, and we also have the point. We can easily find the equation of the line. So the slope, so for part B, m equals dy to dx at the point 3/2 and 3/2. And this is how much? This is 3/2 minus 3/2 squared divided by 3/2 squared minus 3/2. And the answer is -1. So the slope is -1. So the equation of the line will be y minus y naught equals m times x minus x naught. So y minus 3/2 equals -1 times x minus 3/2. And then this one gives y equals minus x plus 3. If you simplify, minus x plus 3. So we can also look at the graph, how it looks like. The graph looks like this. So at this point here, so this point is 3/2 and 3/2. And this line here, it's y equals minus x plus 3, which is the equation of tangent line at this point. Okay, now for part C, we want the tangent line to be horizontal. Horizontal means the slope has to be 0. So we want m equals 0. So that gives dy to dx equals 0. And then y minus x squared divided by y squared minus x equals 0. Therefore, if a fraction is 0, then the numerator has to be 0. So then y minus x squared equals 0. That gives y equals x squared. So y equals x squared. Now, how many points do we have on y equals x squared? Y equals x squared is a curve, it's a parabola. Of course, there are infinitely many points there. And of course, our answer is not all those infinitely many points, right? You can also see from the graph, of course, there are not infinitely many points with horizontal tangent line, right? So y equals x squared, yes, the equation y equals x squared basically is one of the equations that must be satisfied in order to have a horizontal tangent line. But what is the other equation that has to be satisfied? The other equation is the equation of the curve itself, right? Because we are looking for points where they have horizontal tangent lines. So we found out that if a point on a point you have a horizontal at a point you have a horizontal tangent line, then at that point you must have y equals x squared. But on the other hand, if the point is on the curve, well, then the point must satisfy the equation of the curve itself as well, right? So the equation of the curve was given in the question here. So the point x and y that we are looking for that is supposed to have a horizontal tangent line must satisfy this equation because it's supposed to be on the curve. And in addition to this, it must satisfy this equation in order to have a horizontal tangent line at that point. So we can say hence the points or the point with on the curve with a horizontal tangent line must satisfy these two equations. Which two equations? X cubed plus y cubed equals 3xy, and also the other equation, which is y equals x squared. Now I have two equations with two unknowns, x and y. I can try to solve them simultaneously. So I know that I can substitute y with x squared from second equation into this first equation. So y is equal to x squared. So that gives x cubed plus x squared to power 3 equals 3x times x squared. And then this gives x to power 3 plus x to power 6 equals 3x cubed. And then this gives x to power 6 equals 2x cubed. Now if I divide by x cubed, I'll get x cubed equals 2, which gives x equals cube root 2. So x is equal to cube root 2 right? So here, by the way, when I divided by x cubed, well, we can only divide by a number if we know that the number is non-zero. So here it was saying that the point is on the first quadrant, so we could assume that x is positive and therefore non-zero. So assuming x not equal to 0, since x positive in the quadrant 1. So x is equal to, so assuming x is not equal to 0, we could divide by x cubed, and then x cubed is equal to 2, therefore x is equal to cube root 2. And then we can find the y value. How much is the y value? Y was x squared, right? Remember? Y is equal to x squared. So then we'll have y equals cube root 4. So the point with horizon in quadrant 1 with a horizontal tangent line is cube root 2 and cube root 4. Okay, so that's part C, the point with horizontal tangent line on this curve, and you can also see it from in the graph as well. So this is the point, with before this point, like here. Which is basically the intersection of this curve with the graph of y equals x squared. Because we saw that according to our calculation, not for every curve, but for this curve, if a point has a horizontal tangent line, then it must be on y equals x squared, which means this parabola. And of course, the point must be on the original curve as well. So then the point of intersection of these two curves is this point here. Which we found its coordinates. So let me delete this just to make the avoid picture become messy. So what I explained about the point with horizontal tangent line to you. All right. Okay, another important subtopic here basically is how to find the second derivative using implicit differentiation. So finding higher order derivatives using implicit differentiation. Okay, so to find y double prime equals d squared y to dx squared using implicit differentiation, first find y prime as a function of x and y, and then again differentiate both sides and substitute all y primes in terms of x and y. Because once you have y prime as a function of x and y, then if you differentiate one more time, left-hand side, you will have derivative of y prime, which is y double prime. And right-hand side, you have a new function. In your new function, it's possible that y prime will be appeared. But y prime, we already know what it is as a function of x and y, so we can substitute it. I'll show you how. But before doing an example, similarly, we can differentiate y double prime equals a function of x and y. Differentiate both sides of y double prime equals a function of x and y to find y third derivative and so on. Okay, so let's look at an example. So there was an example that we did above for finding y prime. Let me do the same example, but this time we want to find y double prime. So this example, 5y squared plus sine y equals x squared. So 5y squared plus sine y equals x squared. Find y double prime equals d squared y to dx squared as a function of x and y. So maybe in the exam says that find it as a function of x and y, but maybe it doesn't. Even if it doesn't, your job still is to find y double prime as a function of x and y. So in example above, so solution, in example above, we saw that we found the formula for y prime. What was it? Y prime was 2x divided by 10y plus cos y. Okay, so we already know what y prime is. Then here we are saying that to find y double prime, differentiate both sides of this equation. You have y prime as a function of x, right? Now differentiate both sides. And if there are some y primes appeared after you differentiate, you can of course substitute it back because we already know that y prime is 2x over 10y plus cos y, right? So let me differentiate both sides of this equation. What do we get then? So we saw this. Now differentiate both sides. So we get y prime derivative equals 2x divided by 10y plus cos y derivative. Now derivative of left-hand side, y prime prime is y double prime, which is what we're looking for. Now for the right-hand side, we have to use quotient rule because it's the quotient of two functions. So 2x derivative times 10y plus cos y minus 10y plus cos y derivative times 2x divided by 10y plus cos y the whole square. Then we get y double prime equals 2 times 10y plus cos y minus, now derivative of this one is 10y prime. Derivative of 10y is 10y prime. Derivative of cos y, what is it? The usual derivative, which is minus sine y times y prime according to the chain rule. So minus y prime times sine y and then times 2x divided by 10y plus cos y the whole squared. Okay, so we differentiated both sides of the equation we had for y prime. Now what should we do? In the next step, it said that after you differentiate both sides, if there are some y primes appear, you have to substitute them as a function of x and y, because we already know, like we said, we already know y prime as a function of x and y here. We already know y prime is this function here. So now we have some y primes appeared here. So we just need to substitute the expression we have for y prime back here, and then we are done. Because the question asks us to find y double prime as a function of x and y. Right now we found y double prime as a function of x, y, and y prime. So we have to get rid of y prime, and we already know how to get rid of y prime. We just need to substitute the expression we have for y prime back here, and then we'll be done. So y prime is, what is it then? We said 2x over 10y plus cos y. So then y double prime will be equal to 20y plus 2 cos y minus, now y prime, I can take it out between these two terms. I can take out y prime, and also at the same time, let me substitute this expression for y prime. So minus 2x divided by 10y plus cos y times, right? So this expression that I wrote here is the expression we have for y prime. Now y prime, once it's taken out, these two terms, they have y prime as a common factor. Once it's taken out, what will be left inside? 10 minus sine y, and then times another 2x divided by 10y plus cos y the whole squared. I can simplify this further. So this one is 2 times 10y plus cos y squared, and minus 2x times 2x is 4x squared. So minus 4x squared times 10 minus sine y divided by 10y plus cos y, and then divided by 10y plus cos y the whole to power 2, right? See? It seems the screen is freezed. Let me stop share. Okay, so see in the numerator, see denominator, I still wrote it, the same thing. In numerator, 10y plus cos y is the common denominator. And this is 2 times 10y plus cos y. So then it's going to be 2 times 10y plus cos y times another 10y plus cos y. It's going to be 2 times this expression to power 2 minus whatever that is left here, 2x times this guy. So 4x squared times this guy divided by 10y plus cos y. So 10y plus cos y is this 10y plus cos y. And then the whole thing divided by 10y plus cos y to power 2, which I rewrote it again. And then this one, we can just write it as 2 times 10y plus cos y squared minus 4x squared divided by 10y plus cos y to power 3, right? Because there's power 1 and power 2, so it becomes power 3 minus 4x squared, sorry, times 10 minus sine y, and then divided by this guy to power 3. And you can leave your answer like this. So this was an example of finding second derivative using implicit differentiation. You can try, we did many examples today. You can, for any of them, of course, you can find second derivative or even third derivative. The calculation will be a little bit longer, but you can also do third derivative if you want, or any other higher derivative. So the calculation is still straightforward. It could be a little bit long, but still straightforward. Okay, guys, so that's it. So we learned about implicit equation and implicit differentiation and how we can use them to find slope of tangent line and therefore equation of tangent line to the curves with implicit equations. Okay, so thank you and see you next time.